Hello everyone. This video is on the Knewton Alta assignment for section 7.5 called Choosing a Factoring Strategy. Alright, so in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives should be the same, the structure should be similar, so I'm hoping that watching me do these here will help you in some way when you work on the assignment on your own. Alright, so on the assignment page you should have the title, the mastery bar telling you how far along you've gotten, your objectives, and it looks like there's just the one objective in this assignment. And under the current objective, you should have a question related to that objective. And at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. It's for instructors only. But you will have a more instruction button. Right, so if you're ever struggling with a topic or a question, click on this and you'll be taken to a page with some reading or videos to study. Then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so as I mentioned, there's only the one objective in this assignment. It's recognize and use the appropriate method to factor a polynomial completely. Alright, so before I get into this question here, I actually want to talk about, the questions you should be asking yourself, the steps you should be following when asked to factor a polynomial completely. Now, I'm of course assuming that you have done the work from sections 7.1 through 7.4 and all those assignments before this, and maybe seen my videos on those. So I'm going to mention methods of factoring, but assume that you remember how to do them. Alright, or at least you've learned how. Alright, so when we're asked to factor, I'll call this factoring steps or factoring questions. The first step you should follow, the first thing you should do is factor out the greatest common factor, if there is one. You should look at all the terms and see if all those terms have something in common. Factor out the GCF, right, the greatest common factor, or the opposite of the GCF, the negative GCF. That's only when the lead coefficient is negative. Remember, that's something I've been saying in sections 7.1 through 7.4. If the lead coefficient is negative, pull out, the opposite or a negative greatest common factor. Alright, then the second part is, if the polynomial has two terms, right? Basically, it's just the next few steps deal with how many terms does the polynomial you're looking at have. So if the polynomial has two terms, well, then it may be a difference of squares. Which you should know how to factor. A squared minus b squared would factor to a minus b times a plus b, right? A product of conjugates, or a plus b times a minus b. It could be a difference of cubes. right? A cubed minus b cubed. And that would factor to a minus b times a squared plus ab plus b squared, right? This is another formula we brought up in an earlier section. Or it could be a sum of cubes, which is very similar to a difference of cubes, right? Factors in a very similar fashion. So a cubed plus b cubed would factor to a plus b times a squared minus ab plus b squared. And this is it, right? If a polynomial has two terms, the only way you're going to be able to factor it is if it's in one of these forms. Right? If it's a difference of squares, a difference of cubes, or a sum of cubes. Right? Otherwise, it'll be prime. What if the polynomial has three terms? Right, well, if the polynomial has three terms, remember there were only a few kinds of polynomials with three terms, a trinomial that we could actually factor. Is it of the form ax squared plus bx plus c, or ax squared plus bxy, with a quadratic with two variables plus cy squared? If it was in one of those two forms, then you can try the AC method. Right, this is again something I'm going to just write up here and assume you remember what that means. Or you could try factoring by trial and error. Or it could be a perfect square trinomial. Which, again, something you should know the form of based on earlier sections. That's either going to be a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. And these both factor pretty similarly as a perfect square. The first one would be the quantity a plus b to the second, and the second one would factor to a minus b squared. And then once again, you may come across one of these, or it might just be prime again. If the AC method doesn't work for polynomials like these, the quadratics, or if they're not perfect square trinomials, if none of this is happening but it's got three terms, we would then say it was prime. And the final thing here is if the polynomial has four or more terms, but usually we'll just see four terms, right? In the previous sections, we've only worked at polynomials with four terms as the highest amount of terms. But if the polynomial has four or more terms, try factoring by grouping, right? The grouping method. Right. Which again, I'm just mentioning the method and assuming you remember what it means, right, based on previous sections. Now, as I've been saying, if none of this stuff works out, you can just state that the polynomial is prime, right? Prime over the integers, but just prime. Okay, and this is what we got to be thinking about, right? Asking ourselves these questions as we go through. Now, the first example I'm given is a polynomial with three terms. We have a negative 2y cubed plus 48y y squared minus 190 y. Alright, so the first thing I'm doing is I'm pulling out the greatest common factor, which again, I'm not going to go into how to find all that, right? This isn't a lesson about finding the greatest common factor. That's back in section 7.1 or 7.2, right? But you see how the lead coefficient is negative, so I'm actually going to pull out the opposite of the greatest common factor, a negative GCF. And then, all the coefficients are even, so 2 is the largest number that goes in all those, and y cubed, y squared, y, they all have y to the first. So I'm going to factor out negative 2y. Right? And if I factor out negative 2y, the remaining factor will be y squared minus 24y, and then plus 95. All right, 2 times 95 is 190. Right. And again, you can always check your factoring by multiplying. All right. If I were to redistribute, multiply by the negative 2y, you'd get the original expression back, right? You check by multiplying. Alright, so I factored out the greatest common factor, but we are asked to factor completely, right? So now I'm looking at this trinomial here. Alright, now this is a quadratic. This is in that form ay squared plus by plus c. But the lead coefficient is 1, and you may recall, right, with these quadratic polynomials, when the lead coefficient was 1, it was pretty simple. We just had to find factors of the constant term whose sum was the linear coefficient. So what are the factors of 95 whose sum is negative 24? And that would be negative 5 and negative 19. So this is negative 2y that I pulled out earlier, and then this simply factors down to y minus 5 times y minus 19. Right, when the lead coefficient of these quadratics is 1, it's very simple once you find those factors that add up to the middle coefficient. And that's it, right? None of these factor any further. And as I was saying, you check your answer by multiplying again. You check your factoring by multiplying. So if you multiply these two, y minus 5 times y minus 19, you would get y squared minus 24y plus 95, and then you multiply by the negative 2y, and you would get the original back, right? That's the hope, is that when you factored, if you multiply it again and go backwards, you get back to the original, something equivalent to the original expression. All right, and this is what I'm going to type right here, right, in the box. So negative 2y times the quantity y minus 5 times the quantity y minus 19. And that should be good. Now when you submit an answer, you'll be told if you're right or wrong, and then given some sort of answer explanation. Please read through these answer explanations just to make sure you understand why something was correct or incorrect. And hopefully you can learn from your mistakes for future questions. Alright, so next, same objective. We're just given a polynomial and asked to factor it completely. And once again, it's a polynomial with 3 terms. Now remember, you can be given a polynomial with 2 terms, 3 terms, or 4 terms. Right? I don't think they're going to be giving you polynomials with more than 4 terms, but based on what I've seen in sections 7.1 through 7.5. Alright, so I'll write this one out. So we're asked to factor, z cubed plus 79 z squared plus 78z, clearly the greatest common factor of all three of these terms is z. Right? They all have some z, they all have at least z to the first, and that's it. So I factor out the greatest common factor, z, and if I do so, the remaining factor will be z squared plus 79z plus 78. And then just like in the first example, we have a quadratic trinomial here where the lead coefficient is 1. So really all I need to do now is find factors of 78 that add up to 79, and that would be 78 and 1. Alright, 78 times 1 is 78, 78 plus 1 is 79. So we have the greatest common factor z, and then z plus 1 times z plus 78 would be the factors of this, quadratic with a lead coefficient of 1. It's very easy when the lead coefficient is 1. You don't have to go through that entire AC method. Now, if the lead coefficient were not 1, then I would be going through the AC method in its entirety. And that's it. None of those factor any further. We're done. So z times the quantity z plus 1 times the quantity z plus 78. Great. Hopefully they start giving me some different kinds of examples with different numbers of terms. Yeah, here we go. See, this is now a polynomial with 2 terms. Right. So I got plenty of space on this page. I'll just do it here. So the polynomial we're given this time has the terms 40 AD cubed plus 625 A. Alright, so the greatest common factor, again, the first thing you look for in any factoring is the greatest common factor. And both these terms have A in common, and they also have a multiple of 5. Alright, I can see that the greatest common factor is going to be 5A. Alright, so I pull out 5A, and if I remove a factor of 5A from each of these terms, what would be left over would be 8D cubed plus 125. And now we're focused on this, which we will see, it's 2 terms. The only way we're going to be able to factor this is if it's a difference of squares, a difference of cubes, or a sum of cubes. Well, I'm seeing third power here, and it's a sum. I think this is a sum of cubes. All right, let me show you off to the side here. 8d cubed is actually 2d to the third power. Right? There's a cube. Plus, and then 125 is 5 cubed. So here's the a cubed plus b cubed. Right, and I can go through that formula for the sum of cubes if you want to write it out again. Replace all the capital A's with 2d and all the capital B's with 5, and it would look like this. The factors would be 2d plus 5. Remember, one factor was very simple, just a binomial factor where you just get rid of the cubes. And then the other factor was a trinomial factor where it was, the first one squared, 2d squared, then minus, and then the product of these two cube roots, 2d and 5, 2d times 5, and then always plus, and then that second cube root, 5 squared. And of course we simplify this, and I'll do this over here. So we had the greatest common factor, 5a, pulled out, and then this 8d cubed plus 125 we saw as a sum of cubes would factor this way. One factor is 2d plus 5, and then the other trinomial factor is 2d to the second, which is 4d squared, minus 2d times 5, that'd be minus 10d, and then plus 5 squared, or plus 25. And you may recall from the sum of cubes, difference of a cube section, whatever section that was, from 7.1 through 7.4, that if you already pulled out the greatest common factor, when you factor a sum of cubes, that trinomial factor will be prime. Alright, so 4d squared minus 10d plus 25. You could try the AC method if you want, but you won't be able to find factors that add up to negative 10. That will be prime. So this is as factored as that polynomial gets, and that's what I'm going to type. Alright, so we had 5a times the quantity 2d plus 5 times the quantity 4d squared minus 10d plus 25, and that should be good. Excellent. Alright, and then based on the progress, usually it only takes 4 questions if you're getting everything right to get through an objective, so I should just have one more here. Alright, and once again, we're given another polynomial with 2 terms. Alright, so just understand, if you have a polynomial with 4 terms, try that grouping method. Also, we haven't seen any quadratics with a lead coefficient that's not 1. So if you ever come across anything like that, try that AC method. And again, I'm not going to go into the methods, just go back to sections 7.1 through 7.4 material and look it up if you don't remember. Alright, so one more of these. Alright, so here we're given 2-term polynomial, 2d cubed minus 432 q cubed. The greatest common factor here is simply the number 2. It's the only factor in common in both terms. So I pull that out. And then what we're left with, it's going to look like a difference of cubes, right? You have d cubed minus, and then 2 times 216 would be 432. So you have minus 216 q cubed. Right, and then this this binomial factor here is you'll see it's a difference of cubes, and once again I'll do it off to the side. This is a difference of cubes. So definitely d to the third, right? That's a cube. Minus, and then 216 q cubed is 6q to the third power. Right, there's your difference of cubes. Right, so that'll factor to d minus 6q times, and then d squared plus d times 6q, and then plus 6q to the second. Right, we'll simplify that when I write out my final factorization over here. So we had the greatest common factor, 2, pulled out, and then this d cubed minus 216q cubed factors to d minus 6q times, and then the trinomial factor is d squared plus 6dq plus 36d squared, or q squared. And that's as factored as that's going to get. And that's what I'll type. Two times d minus 6q times d squared plus 6dq plus 36q squared. Alright, and that should be good. Wonderful. Alright, and that should be it for this preview version of this assignment. Now, like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself. And I didn't do, they didn't give me a question for every single possible scenario. Right? I didn't see any differences of squares. I didn't see any perfect square trinomials. I didn't see any quadratics with a lead coefficient that wasn't 1. I didn't see any polynomials with more than 4 terms, or 4 terms or more. So I didn't use the AC method here. I didn't do the grouping method. But again, that's not what this is about, right? You learned those methods in previous sections, so you should be able to use them. All right. But the objectives are the same here, right? The objective's the same. It's the same objective for all the questions. Just, do you know how to factor completely? Go through the steps, go through the procedure. And the structure should be similar, the setup's the same. So I'm hoping that watching me do these 4 here, again, even though it didn't cover all the scenarios, helps you out in some way when you do this on your own, right? But definitely have this factoring steps in your head, right? At least have this much. Right? What you should be thinking about when looking at a polynomial, right? First thing, factor out the common factor, or a negative common factor if its lead coefficient is negative, and then you just go through different possibilities if the polynomial you're looking at has 2 terms, 3 terms, or 4 terms. All right, and thank you very much for watching.